All right, this next problem, they want us to find the tangent line of this polar equation, 1 minus cosine theta at pi over 2. So if we're going to find tangent line, one thing we're going to need to know is what is the point and what also is the slope. Let's start with point. So our point here, we know x is going to be equal to r cosine theta, and y is going to be equal to r sine theta. So now let's plug in what we know r is. R in this problem is 1 minus cosine theta times this other cosine theta that we already have, and then our y value is going to be 1 minus cosine theta times sine theta. Well, if we want to find it at pi over 2, that means we want to plug it now pi over 2 in for here and see what we get. So we're going to have 1 minus cosine pi over 2. Another cosine pi over 2 here. And then let's evaluate that one. Cosine, remember, is our x value. Pi over 2 is 90 degrees. Our x value at 90 degrees is going to be 0 on unit circle. That would be right here. That's the point 0, 1. So both of these are 0 here. We got 1 minus 0 times 0, which is just going to be 0. So our x coordinate is 0. Let's do the same now with y. This would be 1 minus cosine pi over 2 times sine of pi over 2. And we've already just established those values. Cosine is 0. Sine is going to be 1 at 90 degrees. And so here we got 1 times 1, or 1. So it looks like our point here that we're going to need is the point 0, 1. Okay, so now let's find, the other thing we're going to need to find is what is our slope. So to find our slope, that's using, or finding dy dx, and in polar form, that's our dy d theta over our dx d theta. So we got to find those two derivatives. So we got our x and our y right here. So let's do the derivatives. Let's start with the y one since it's on top. So we're going to have to do product rule there. So it's going to be first one times derivative, the second one, derivative sign is cosine, plus, now we got to switch them around. So it's sine times derivative of 1 minus cosine. Well, derivative 1 is 0. Derivative of cosine is negative sine, but it's already negative, so that's going to make it positive sine. On bottom, let's do the derivative of the x now. That's also product rule here, so 1 minus cosine theta. Derivative of cosine is negative sine. Now switch them around, so cosine times derivative of 1 minus cosine. Derivative of 1 is 0. Derivative of negative cosine is going to be positive sine. All right, so now we want to find what is this at our same angle here. What is dy dx when our angle is pi over 2? So we've already talked about what those values are. Cosine is 0 at that. So that's 0 plus sine of pi over 2 is 1. So we got 1 times 1 here. On bottom, we got 1 minus 0. Derivative of sine is pi over 2 is 1, so this is going to be negative 1. Cosine is 0, and that's 1. So evaluating this on top, that's going to be 0 plus 1. On bottom, we got 1 times negative 1 is going to be negative 1. 0 times that's 0. So it looks like our slope comes out to be 1 over negative 1, which is negative 1. So that's our slope. And the final thing now, they did want a tangent line, so now we just got to put that together. We had our slope, we also had our point being 0, 1. So if we do like point slope form or something like that, we can get our tangent line up. So we got slope being negative 1, this is 0, this is 1. that would be good enough on the exam, but this one's not too hard to simplify here. If we distribute, that's just 0 there. And so final equation here would be y equals negative x plus 1. That would be the tangent line to this polar curve at pi over 2.